equation of a straight line. One is y equals mx plus c. 2 is the 2-point form like we have done, which says y minus y1 over x minus x1 equals y2 minus y1 over x2 minus x1. And finally, the third one, which says y minus y1 over x minus x1 equal to the gradient, and that is only because we have considered this to be the gradient of a straight line. In other words, when examiners give questions, be very careful to understand the nature of that question so as to map it to the formula that you are going to use to solve the problem, if you understand what I mean. Now, also, when you look at a graph, what is the nature of a line when you want to tell the gradient? Take, for example, I draw a straight line this way. This is rise over run. So, rise, run. And if this is rise over run in this direction, in the positive, that is as x is increasing, y is also increasing, then you say this is your line L, let me call it L1, is having a positive gradient or slope. On the other hand,
wait, isn't that when it's facing that way, like when the line is like that, it's positive?
Because you will notice that as x is increasing, you can see, let's say this is at the point. Okay, as x is increasing, y is also increasing. You can see that.
Yeah.
So there is no way we are going to get a negative slope when you have both axes increasing in values. However, let us consider a situation whereby the graph goes this way. What did you notice?
Yeah, I noticed.
This is more like a drop of a run. So you see, your x value keeps increasing, but your y value keeps going down. In that case, this line, let us call it L2, will have a negative slope or gradient. You say slope in British, then in America you say gradient. In Nigeria, you can use both of them, both slope and gradient. Now, let me say that this is only when you consider rise over run or drop over run. What about a situation where the graph or your straight line is parallel to either axis? So let's say this is your line L3. What have you noticed, Mira? There is one point on this, right? your x value will not change. Rather, your y value can change at every point in time. Did you see that?
Yeah, I do.
In other words, delta y, that is changing y over changing x, will be equal to, because y is changing, but x is not changing, it's static. So your x2 minus x1 is going to be 0. Can you see that now?
Yeah, I can.
For this one, a number over 0 says that your slope is undefined. In other words, line L3 has an undefined slope. Now, let us consider a situation where your graph is parallel to the horizontal axis. So I am going to call this line L4. What can you tell me about this as against the one we did last?
The difference between what I want.
This we did last and this.
I don't know.
If you're paying attention, you will notice that first, the L3 is parallel to the vertical axis, but your L4, in the other hand, is parallel to the horizontal axis. Are you not saying that?
Yeah, I'm saying that.
So if it's parallel to the horizontal axis, and I told you that the change in x in this one is equal to 0, what will happen? Look at it and tell me something about this graph. What is going to change and what will not change?
The y is going to change.
The y
But
is
the
going
x-
to change. But the
The
x,
x one.
okay, it means you are not looking at it using the geometric highs. X is
X.
always changing, but y is constant. It means that delta y over delta x equals delta y can change, so the change in y will be 0 over delta x. And at every point in time, 0 over a number will always give you 0. It means that the line L4 has a slope of 0. Okay? Do you understand that now?
I do.
Now,